Uh, Hello, everybody. Thank you for coming for this webinar. We are very glad to see you online and all of you are well at this special time. I hope your team and all your families are doing well. I'm Roy Wang from DINSTAR marketing team. Here, I'm joining with Lich, our engineer and expert of VoIP and SBC during this webinar. Today, we will have an introduction about session border controller, usually simply called SBC. What is SBC? Why do you need an SBC? Then we'll have a look at DINSTAR SBC family and some typical applications of SBC in enterprises and service providers network. Okay, let's get started. What is a session border controller, SBC? Here we can see a definition from Wikipedia. Session means a communication between two parties. In most VoIP applications, you can simply think it as voice calls. A session consists of signaling and media. If you SIP, then it is called a SIP session. If you use H323, then it's called H323 session. In VoIP, media is mainly what we call RTP. Usually, session of SBC could be SIP session, RTP session, and web RPC session. Border. SBC is situated at the edge or a border between two networks, usually between a trusted network, for example, your enterprise network, LAN, and an untrusted network, for example, public network, WAN, internet. The controller refers to the ability of SBC to control, allow, delay, transform, and end each session that traverses the border. SBC sets up various of rules and controls on signaling and media behaviors to ensure the security. For example, set up access rules to block the calls and registration. Set up bandwidth rules to ensure every trunk to get enough bandwidth and ensure voice quality. SBC is currently a bridge of different networks. For example, as an enterprise, all endpoints outside are untrusted. Some endpoints may be thieves sneak into your network enterprise. They are hackers. Then we need an SBC as a bridge to build trust between different networks. From one network to another network, before delivery, SBC will do the standardization work. Every packet should conform to the SBC's rule, both signaling and media, including source IP, domain, message content. If not, SBC will deny it. So the SIP registration or call cannot be established. This is called controller. On the other hand, as a controller, SBC should be powerful enough to end all kinds of attacks and do the controller's work. Sometimes people may say, I have an IPPBX with firewall. In fact, you cannot put all burdens on your IPPX because this requires enough resources on hardware or software. Your PBX have a lot of other works to do, so you need to put the burdens off from your IPPX and leave it to professional SBC. In one word, you can think SBC as a SIP or VoIP firewall. The most important function is security and protecting your VoIP network. But in fact, SBCs are so much more than that. That is why SBC plays more and more important roles in NGN or IMS network. We've already mentioned some features, and we will talk about more in details. So why do you need an SBC? From our experiences, usually when you set up an IP telephone solution or VoIP system, there may be three kinds of issues you have to handle with. The first one is connectivity issue. No voice or one-way voice caused by different reasons. Now, when we are talking about the remote working, telework, or work from home, this issue is more and more common. The second one is compatibility issue. SIP compatibility issue between different devices and different vendors, like your IPv6 and your IP phones, your IPv6 and VoIP gateways, your VoIP system with different SIP trunks providers. The third issue is security. There are tons of threats on the internet. Some may cause your system crash. Some cause toll fraud, may even use your money to make expensive international calls, leaving a big bill to you. Here we only have a list of some, not all, like intrusion of services, eavesdropping, denial of service attacks called DOS or DDoS attacks, data interception, toll fraud, SIP malformed packets. All of these, seriously, you cannot only rely on your data firewall. So let's see how SBC will resolve on these three issues. The first one, connectivity issue. About connectivity issue in most cases is caused by NAT. Here you can see illustration. Many of our customers asked why my NAT setting is normal, but audio and video are abnormal. NAT is network address translation. This is where a device like a router or data firewall translate one IP address to another, like translate private IP to public IP. However, SIP is an application layer protocol. Here you can see also the OSI layer model. You can see there are three layers. SIP is an application layer protocol. For router or data firewall, this is SIP or RTP message only as an UDP or TCP message. They don't really know it is a SIP message. Also can't analyze the IP address and port number in SIP message. So what is listed in the headers and UDP might not match the actual IP packets. There would be connectivity issues. So there comes the SBC. The function, the function can let traversal. As a firewall of application layer, SBC can identify the contents of SIP RTP message, obtain correct IP address and port number of signaling and RTP media, then solve the connectivity issue. SBC till now is the easiest and best solution on this. Moreover, SBC acts as a proxy for VoIP traffics to overcome the hurdles of NAT. So there won't be complex networking like the topology in the left you can see on the screen. while you are making calls between two branches, signaling has to go through the headquarters, but media has to pass through the firewall between two sublets. So you need to create lots of routing rules between these sublets, which makes the networking more complicated. With SBC, you don't need a VPN for VIP traffic. You can simply set up a connection between branch to headquarters. All signaling and media of VIP calls will be forwarded by SBC. For now, it shows the importance, especially for work from home staff or remote agents in call centers. The second issue, compatibility issue. Now market offer us plenty of choice on safe devices. So it is real normal that you have safe devices from different vendors. You may ask, all my safe devices support safe. Why there are compatibility issue? Unfortunately, interoperability between safe products of different vendors is not always guaranteed. The reason is SIP is a standard, is an open standard. Different vendors have different interpretation and implementations, which can cause connectivity or no audio issue. SBC supports SIP normalization via SIP message and SIP header manipulation, regular expression, and programmable adding, deleting, modifying are available in DINSTAR SBCs. There is another reason of compatibility issue. Different networks adapt different voice codecs. For example, the service provider may use G729 to save bandwidth and improve efficiency. Your office IP telephone system may use G711 or wideband codecs for better voice quality or high definition voice quality. SBC offers seamless transcoding of various voice codecs. So solve the compatibility issue caused by different codecs in different networks. Last issue, maybe it is the most important, security. You already know it is never a good idea to expose your enterprise network without any protection. So you add a firewall to protect your data. When you open the firewall to allow safe traffic, also you cannot leave your IP telephone system unprotected. SBC is designed to understand safe traffic and provide extensive protection on your VIP system, like your IPPX. There are many features like access control list, we call it ACL, blacklist, traffic control, malformed packet protection, intrusion protection, and intrusion prevention, DDoS attack protection, recognize and prevent denial of service attacks, topology hiding, TLS encryption, SRTP encryption, which the data firewall cannot process. So there are tons of security features on SBCs. Here, we will take a close look at two features. The first one, attack protection. All behaviors of some VIP attacks conform to the protocol. It is no problem on protocol, but its behavior is abnormal. For example, if the call frequency is too high, it will cause damage to your VIP infrastructure. The firewall cannot help on this at all. However, SBC can analyze the application layer and identify user behaviors. The second is called overload protection. For traffic flood, in this case, hot events are the most common trigger sources, such as Black Friday in USA. There are a lot of people doing shopping. There are a lot of people calling the service, or attacks caused by elective news. So a sudden surge of registration caused by data center power failure or network failure is also a common trigger. SBC can sort traffic intelligently according to user level and your business priority. With high overload resistance, functions like traffic limitation, traffic control, registration rate limiting, call rate limiting are very helpful in these cases. Next, let's look at two common misunderstandings on SBC. The first is, do I need an SBC when I already have firewall? The answer is yes. Firewall works at level 2 to 4, mainly for your data security. It is you can think it is a low but wide wall, but it's not high enough for your VoIP traffic because he's for data at layer 2 and 4. SBC works at layer 5 to 7, designed especially for voice and video traffic. There are also many features about voice and video traffic are not available on firewalls. So like we list in this list. So this is make SBC an essential network element of your IP telephone system. The second misunderstanding is, do I still need an SBC in addition of VPN? The answer is also yes. VPN will secure the device, like your IP phone, soft phone, or your IP gateway, but you are still opening up ports for your SIP providers. You must also consider the fact that your user may connect an infected PC or laptop to that phone, which would have a secure connection directly to your LAN. The same thing applies if your user are using a soft phone over VPN using infected devices. Furthermore, when there are complex multimedia or when your IP network is not stable enough, SBC can ensure the quality of services. Also, the hardware redundancy and the powerful routing features also offer high availability to ensure your business continuity. Okay, next we will see DINSTAR session border controller family. So right now, DINSTAR are offering 3 kinds of devices. SBC 300 is for small and medium-sized business. It supports 5 to 50 SIP sessions and up to 50 transcoding calls. And SBC 1000 is for enterprises, support 50 to 500 SIP sessions and up to 200 transcoding calls. And SBC 3000 is for service providers and carriers, support 500 to 2000 SIP sessions and up to 1200 transcoding calls. Here is a list of DINSTAR SBC features. Most of the features we already talked before. Here I want to give an emphasis on the hardware redundancy features. DINSTAR SBC of all models support 1+1 active standby hardware redundancy. So this is ensures a high availability. The switch over, for example, when one of your SBC is down, it will switch to the redundancy, the standby one. The switch over is happened in milliseconds, so your cores won't be disconnected, and the users will have no sense on this at all. Here we list some reasons for you to choose DINSTAR SBCs. The first one is more investments. When talk about SBC, many people think, oh, it's very expensive devices. In fact, not for DINSTAR. SBC 300, our entry level, is start from 5 sessions only. So this is small budget on micro or small enterprise. The second one is reliable design. This SBC is designed by the best team in DINSTAR as experts from Canada and China who have been working in communication for more than 15 years. So we give our best man on this product line. The third one is full protection. We offer the full features on SBC to prevent your frauds and attacks and give you the security. The fourth one is flexible scalability, because our scalability of SBC can increase by simply software license, and your business won't be down. So this is very simple. Also about the fifth one, simple license is we don't need additional license on other features of SBC. So it's always full features. The license is only about the compatibility. And sixth one is the fast support. Well, you already know you are our old friends, so DINSTAR offer a professional support team is ready to help you on the deployment, maintenance, and debugging. Okay, next we will see DINSTAR session board controller applications, and you will know where is your customers. The first one is secure communication of remote offices for enterprises. For remote working, SBC can be deployed to ensure the connectivity, which we have explained before. At remote agent side, as because they don't engineers they don't know much about technical, so they can't do the complex setting. So because for with SBC you don't need an extra VPN, so this will make things much easier for you. Also, you can they can keep their original extension numbers. For call centers connect the remote agents, it is similar. They need the remote agents to work from home, always connected. Also, the security is very important. We provide SBC to China's second largest e-commerce platform. The stability of their call center is very critical to their business because they have a lot of online shoppers. So the high availability, which we have mentioned, the 1+1 hardware redundancy are essential in these cases. When enterprise access to different SIP trunk providers, the SBC can provide failover routing, load balancing, list core routing, usually called LCR, while managing all interoperability issues we mentioned before. So when we talk about SIP trunking between service providers and carriers, or carriers interconnections. So SBC not only protect their own networks, but also ensure the compatibility between these networks. Here we list some industry users may need SBC, like the financial bank, insurance, or government agency, logistics company, education, taxi, online retail, call centers, service providers. Here you can see these are successful cases, like the biggest social media giant in China, Tencent, the biggest impress company in China, Shunfeng Express, the biggest private bank in China, the second largest e-commerce platform, and some providers we list here. So, okay, now Lish will show you our demo of SBC and then answer your questions. Let's welcome Lish.
Hello, everybody. I'm Rich. So I see a lot of you guys are my friends. So today, let me show you the web interface, the demo of which deployed in our office. So I show the web interface here. So for our SBC, you can see it. We list our navigator. It includes overview, service, security, system, and maintenance. So you can see on overview page, you showing different status of like access network, access chunk, core chunk. So now I will show you some basic concept of access network and access chunk and the core chunk. You can see this is very basic topology of the real application of our customer. Like in the customer's office, there's IPPX, and she wants to make a chunk to different ITSP, and also they include some of the remote agent which you may use the IP phone or SIP endpoint which need to register remotely to their office. So you can see this topology like access chunk. So we have to create a access network for the remote agents that which the SIP endpoints may register through their on their mobile phone, through the internet. So we need from the SIP endpoint to the SBC, we call it the access network. Access chunk is the SIP chunk between the ITSP and SBC, which is from the least part, like the IP 211 to the Ethernet port of 0 of the SBC. So this part we call it access chunk. The core chunk is it's the SIP chunk between SBC to IPPX, which is this part. So IPPX will send and receive calls to the ITSP, so we call it this part. IPA, this part is the core chunk. Now let's go back to our web interface. So you can see the basic is we create the access network for SIP endpoints, create access SIP chunk to ITSP, create core SIP chunk to the IPPX. So and after that we add some of like routing tables between these chunks, like the SIP endpoints to the core chunk, or local zip chunk to the access chunk. So then then you will be like make calls between the ITSP and the IPPX. So just now Roy showed you like the features of SBC. So I want to show you on web interface, like why SBC can work as a zip firewall. So you on our web interface, you can see like we have a lot of parameters, so we can a lot of parameters. So like what can help you to like protect the attacks and the limit and the like we can create the blacklist and the whitelist, zip head manipulation, register source, unlimited register source IP or IP range, or at some domain field. So when we just like a data firewall, when you work with a data firewall, you have to open like a UDP ports or TCP ports add a lot of rules in the firewall. But as a zip firewall, why it's called a zip firewall? Because we can add like we add the blacklist, like a blacklist of your caller or code numbers. We can limit the numbers you want to call, or you don't want to call. So we limit the numbers, and also we can change the zip message, like the NAT. We translate the UDP port and the TCP port between the private IP and the public IP. So and we can modify the register source. We can limit the register source IP from like the zip endpoint may register from the overseas countries. So we can add the limited IP register source, and so I want to show you on in the zip message, like this is our like a call request, like invite. I think for the technical guys may know this well. In the zip message, actually all the information all included in the zip message. We create the zip chunk, we create like a number manipulation, we create a lot of rules in the SBC, but all the rules may include the list part in the zip message, like we do number manipulation for the caller or for the code number. So all of them include here, like we for the zip head manipulation, we can change all the field, all the field in this in the zip head part, like a request line, or we limit the domain name, or we change the caller, or we change the user agent. Everything can be done in the SBC. So it's like a firewall. You can enable or disable. You can change everything. That's why we call it SBC can work as a zip firewall. So it's SBC. It's a firewall of the zip. It can do everything of the zip. Relate change, relate modify your everything. The second part I want to talk about is network hiding. Actually, how SBC implement network topology hiding, like because we on the SBC you may have several network ports, or so we can create like create VLANs for different networks. Like you want, like SBC may need to connect to different telecom operators. You know, for in most of situation, like especially in IMS, the operator may give you an independent IP address. They may give you a fiber include IP address. So if you want to connect SBC to like 4 or 5 operators, so you need to configure like 4 to 5 IP address inside to the SBC. So this is a big problem, like because a lot of device actually may have only one uplink port, or so how can you configure more IP address in the same network port? So that SBC can be done like this. So you can add like VLAN with like, it's just like a virtual network port, which we usually configure in Linux. So, and also this is one side, like we have GE0 is connect to the ITSP, and another ports we may configure IP address for IPPX. So for the actually for the IPPX side, they don't know the IP of the ITSP. So we call it's just like the hiding the network. They don't know, or the IPPX don't know the ITSP is on public or on private IP. They don't know actually. So we just like you can see this diagram, like we can figure different IP segment for the ITSP, for the IPPX. So they don't understand. They can't communicate. IPPX and the ITSP cannot communicate each other directly. So all the data packets has to forwarded by the SBC. Like we include a public network part and private network part. So it's protect the IPPX from the public attack. Also, I want to talk about rate limit. Actually, we can create a lot of rules in the SBC, like limit registration, like we call it call per second. Like usually, you know, without the SBC, maybe the endpoints like cell phone, IP phones may register to the IPX directly. So sometimes when let's say the IPX storm, maybe after one or 2 minutes after IPX going up, so all the like SIP endpoints may send a register request to the IPX at the same time. So it's like a type of fraud, register fraud. I mean, if you have like 200 or 1,000 of SIP endpoints send register request to the IPPX at the same time, it will be a huge problem. The IPPX may overload, and the system may broke down. So with the SBC, we can limit register request, like it's like a pipe. So the SBC may at the same time register like 20 or 40 register requests per second. So it's like a pipe. It's more how to say, it's more smoothly. it won't like flood all the requests to the PBX and so it's protect the PBX for the core. It's the same, like especially for the call center, we especially in China we use like AI robots, so they send the huge calls to the PBX. So it's we use the SBC to like limit the call for every each second we may accept 40 or 100. So it's make the system works more smooth. So we can see the list rules can be we have a lot of like rules can be done in our SBC, like rate limit. We can configure rate limits. RPS is a register per second. CPS is call per second. We can limit for each chunk, each chunk. Like we limit for the access network. We limit for the access zip chunk or the code zip chunk. Okay, like we also like config. We can add number manipulation rules like time profile, rate limit. Okay, and zip header manipulation. You can see it's very flexible actually. It's zip header type like zip request, zip response. So when you can see more details. So a lot of you can see I just talked about the request in this zip message. So all these part, all these parameters are included here. Okay, so now I want to talk about anti-attack. Like we actually SBC have the features like DDoS attack protection. We have you can see these features on our web interface. We have we can configure. We have especially for the security, like ICMP front or TCP node or something like that. We call it the DDoS attack, and also we can add rules for like access rules. You can definitely you can set like for the web server or SSH anything you can control on our web interface. Here we can add we can block the IP address based on the traffic, like we can limit like we can set the traffic okay for like 1 mega for IP. If the IP overload or use a lot of bandwidth, we can the system may the SBC will block them automatically. This is the SIP security, like for the SIP, a lot of SIPs attack on the public net if you deploy your IPv6 on public network. So we can add rules we can define it like IPv6 receive how many, like we define it like 10. We can like 10. We receive the 10 calls. We can block the IP. Like we receive like 10 register in 5 minutes or 2 minutes. Then the SBC the SBC can block them automatically. You can see the options: IP attack or user attack. We can add the rules based on registration or course. After, like we set we set 4 times, then if the SBC lists 4 registration, like in 4 minutes, then in 1 minute, then it will be blocked. The IP or user, the SIP account will be blocked by the SBC. Then the request won't be response anymore. So this is for this part is for the basic, like for the upgrade or like lessons, or for the configure the network maintenance. We have different logs, like login logs, operation log, security logs. You can a lot of parameters are here. You can do like network capture. If you have any web issue, we can capture on SBC directly and download the capture file and analysis by the Wireshark. So for the technical part, so if you have more technical issues or any questions, so you can pay me on Skype or WeChat.
Okay, if no questions, that's all for today. For next webinar, we will show you our new products, including DINSTAR Powerful IPPX UC 2500 and UC 1500. And also we have a new hardware theory about voice over IP GSM or LTE 4G gateways. So you can join us for our new products. So thanks again for coming and joining us, everyone. And we wish you all the best. See you next time.